So picture this. You're just browsing your favorite sites, checking comments, clicking a few links, just another day on the internet. But what if the very trust you have in those websites could be twisted and used against you? Well, that's the hidden threat we're going to pull back the curtain on today. I bet you've seen a pop-up just like this and thought, ugh, what a weird glitch. But in the world of web security, that's not a bug. Oh no, that's a trophy. It's proof positive that an attacker just successfully ran their code inside your browser on a website you thought was completely safe. It's a pretty chilling thought, right? The idea that a totally legit site could become the weapon for an attack using its own good name to trick your browser. This is the whole idea behind a really common and really dangerous vulnerability. This threat has a name: cross-site scripting, or XSS for short. And it's a particularly sneaky kind of attack because its entire game is based on betraying the trust you automatically give to a website. Okay, so here's the key thing to get. The attack isn't really happening on the website server somewhere far away. It's happening right inside your browser. The website is just the unwitting delivery service for a nasty script, and your browser runs it because, hey, it thinks the code is coming from a source it trusts. Let's break it down nice and simple. First, an attacker finds a weak spot, maybe a comment section, and plans some malicious script. Then you come along and just load that page like normal. The server, which has no idea anything's wrong, sends you the page, attacker script, and all. Your browser sees the script, thinks, oh, this is from that site I trust, and poof, it runs it. Attack's done. Now, not all XSS attacks are created equal. They actually come in 3 main flavors, and each one has a slightly different way of sneaking its malicious code to you. Think of stored XSS as digital graffiti. The attacker basically sprays their malicious code right onto the website's wall, say in a forum post. It just stays there permanently, hitting anyone who comes to look at that wall. Reflected XSS, on the other hand, is more like a custom prank link somebody sends you in an email. The bad code is in the URL itself, and it only works on the one person who clicks it. It's temporary and it's personal. And then you have the ghost, the stealthiest of the 3, DOM-based XSS. This one is wild because it's completely invisible to the website's server. The whole attack happens after the page is already loaded in your browser. The malicious script just manipulates things right there on your machine, which makes it incredibly hard for traditional security to even spot. So, we've seen how these attacks get in, but you might still be thinking, why should I care? It's just a silly pop-up box. Well, that pop-up, that's just the smoke. The fire is a whole lot scarier. You see, a truly malicious script isn't there to show you an alert box. It's there to steal your session cookie. This little piece of data is basically what keeps you logged into a website. It's like a temporary keycard that tells the site, yep, this person's legit, let him in. And once an attacker gets their hands on that keycard, they don't need your password. They don't need anything else. They can just use that stolen cookie, walk right in, and pretend to be you, giving them full access to your account. And the stakes are huge. We're talking stealing your passwords, your credit cards, hijacking your entire online identity. Attackers can deface websites, spread malware, or even set up fake login pages to trick you into giving up even more info. It's a single, tiny vulnerability with a massive blast radius. Okay, that was all pretty grim, I know, but here's the good news. XSS is a problem we know how to solve. It just takes a smart, multi-layered approach to defense. The first line of defense is built on a simple principle: trust nothing. Developers have to treat all user input like it's radioactive. They sanitize it, stripping out any dangerous code, and then they escape it, which basically tells the browser, hey, this is just text, don't you dare try to run it as code. And that cookie theft? Setting a simple HTTP-only flag makes the cookie invisible to scripts, stopping that attack cold. But if you really want to bring out the big guns, there's a powerful, modern defense called a Content Security Policy, or CSP. This is a game changer because it gives developers precise control over what their website is allowed to do in your browser. I love this analogy. Think of a strict CSP as a bouncer at an exclusive club. It has a very specific guest list of approved scripts. If any other script shows up, like one an attacker injected, the bouncer just says, nope, you're not on the list, and blocks it at the door. The attack never even gets a chance to start. So it all comes full circle, right back to that idea of trust. XSS works by taking the natural trust between you and a website and turning it into a weapon. The best fences are all about reinforcing that trust by giving the browser a clear set of rules for what to do and what to reject. And this really leaves us with a critical question for how we live our lives online. The whole web is built on a foundation of trust. So the real challenge for developers who build these sites and for all of us who use them is making sure that trust is something that's always being earned and actively protected, not just taken for granted.